everyone, our team is composed of Yusr Ben Salem, Céline Lefri, and Hind Barakat. In this video, we'll present our project about forecasting using the Inditex case study. We'll start first with an introduction. Second, we'll see the qualitative approach to forecasting. Third, we'll focus on the quantitative approach on which we based our forecast of the sales and demand of Inditex. And finally, we'll end with a conclusion. So Inditex is one of the biggest fashion groups in the world, having 7,200 stores in 93 different markets worldwide. The company owns chains like Zara, Massimo Dutti, Bershka, to only name a few, which are all present in Tunisia and from which we most likely all shopped. In the apparel industry, and especially for groups with such notability, forecasting is a challenging endeavor. By definition, forecasting is the process of predicting a future event. It is the underlying basis of all business decisions. In fact, it helps make the right ones, for example, in identifying requirements for which the supply chain must schedule, inventory, and operational resources. Let's start with qualitative methods. Qualitative forecasting is an estimation methodology that uses the knowledge of highly experienced employees and consultants rather than numerical analysis in order to provide insights into future outcomes. It is used when data is not available and is developed by using surveys, customer feedback, and consensus meetings. Qualitative methods are mostly used when we need to introduce new products and/or services and when we need to predict future trends. For example, when the movie Marie Antoinette was released in 2006 and became a total hit in Europe and in the US, Zara took advantage of this and introduced to its stores puffy ball gowns and jackets from velvet with golden buttons that reminded the customer of the movie and the style of Marie Antoinette. Qualitative methods are also used to create a preliminary forecast which will be adjusted with a quantitative review afterwards.
Quantitative methods. Quantitative forecasting models are used to forecast future data as a function of past data. They are appropriate to use when past numerical data is available and when it is reasonable to assume that some of the patterns in the data are expected to continue into the future. These methods are usually applied to short or intermediate range decisions. Previous research shows that different methods may lead to different levels of forecasting accuracy. The naive method. The naive forecasts are the most cost-effective forecasting model and provide a benchmark against which more sophisticated models can be compared. This forecasting method is only suitable for time series data, and using the naive approach, forecasts are produced that are equal to the last observed value. This method works quite well for economic and financial time series, which often have patterns that are difficult to reliably and accurately predict. In our case, we used the sales forecast because it's very hard to predict the demand forecast in the fashion industry. So we have the sales in million euros, and the forecast of 2011 is the same as the previous year, so it's the forecast of 2010 and so on for all the years. To calculate the mean absolute deviation, we have 13,793 minus 12,527, so the actual sales minus the forecast, and we obtain 1,266. We do that for all the years. We then calculate the sum, which will we obtain 10,748, and we divide that by 6, so we obtain the value of 1797.33. To calculate the mean squared error, we calculate the value of 13,793 minus 12,527 squared, so the sales minus forecast squared. We do that for all the years. We divide that by the sum of n, so it's 6, and we obtain a value of 3,723,651.33. To calculate the mean absolute percent error, we calculate 100 times 13,793 minus 12,527, and we divide that by 13,793 over, and we do that for all the years. So it's 100 times the forecasting error divided by the actual. So we obtain a value of 58.66. We divide that by 6, so we obtain a value of 9.77. The next method is weighted moving average. It's a type of moving average that assigns a higher weighting to a recent price data that does the common simple moving average. This average is calculated by taking each of the closing prices over a given time period and multiplying them by its certain position in the data series. Once the position of the time periods have been accounted for, they are summed together and divided by the sum of the number of time periods. In our case, we have weights of 1, 2, 3 and a 3-year moving average period. So the forecast of 2013 is 12,527 times 1 plus 13,793 times 2 plus 15,946 times 3. We have a value that we divide by the sum of the weights, which is 3 plus 2 plus 1 by 6, and we obtain 13,518.83. We do the same for all the resting years. For the MAD, MSE, and MAP, it's the same method are applied in the naive method. It does not change. The third method is exponential smoothing. So exponential smoothing is a rule of thumb technique for smoothing time series data using the exponential window function, where in the simple moving average the past observations are weighted equally. Exponential functions are used to assign exponentially decreasing weights over time. So we choose alpha equal 0.2. So the forecast of year 2012 is calculated as the previous forecast, which is 12,927 plus alpha, which is 0.2 times the actual minus forecast. So 0.2 times 13,793 minus 12,527, and we obtain a value of 2,768.62. We do the same for all the years, and like all the other methods, MAD, MSE, and MAP, we use the same rules as before.
As for the last quantitative method, which is seasonal method for demand forecast, the multiplicative seasonal model can adjust trend data for seasonal variations in demand. Seasonality may be applied to hourly, daily, weekly, and monthly, or other recurring patterns. In this case, we use the seasonal method to forecast the demand. Statistics have shown that a customer visits Inditex group shops on average 17 times a year. In this table full of numbers is a study on the number of visits of 100 persons over the 36 months. Seasonality used here is monthly seasonality. So let's take the first month, which is January. On the first year of January, 12 visits were made by 100 persons. Second year, 14. Third year, 10. The average annual demand is the sum of visits over the years over the number of years, which is 3. This results 12. The average monthly demand is 17 over all the 12 months. It's a fixed average monthly demand. The seasonal index is average annual demand over average monthly demand, which results on 0.7. In conclusion, forecasting plays an important role in basic operations management as an input for planning activities. Poor forecasting can lead to stockouts or high inventory, obsolescence, low service levels, rush orders, and inefficient resource utilization. As such, demand forecasting is a popular research topic, and many models and methods for forecasting have been proposed over the past few decades. However, in fashion industry, products are usually characterized by short selling seasons, long replenishment lead times, and almost unpredictable demand, and therefore makes forecasting very difficult to make and inaccurate. In this project, we try to develop our own forecasting of the demand and sales of Inditex and Zara in particular. There is still an opportunity for Zara and Inditex to further their research efforts in demand forecasting and replenishment optimization. We suggest that spend more time tuning the model so that it can adjust faster to monotonic trends, because a store's annual demand rate would vary significantly over one year to the next, and for stores where demand is changing monotonically, this approach would lack reality. Thank you.